So hi, this is Jen Labaon, and today we're going to answer our number 5. So what does this figure tells you about the relationship of how signal is represented in time and frequency domain? So this is our diagram, but before we're going to explain this one, let us all remember that in every rotating machine there is the rotating machine has individual parts, and it has a vibration. So sometimes rotating machine experience an unbalanced operation due to any kind of causes. So let us start to explain this one. Example, this is our machine. If there is unbalanced operation within this machine, the amplitude will going to takes place. So it means that if the amplitude will change. So for the definition of our time domain, with regards to its relationship with the frequency domain, our time domain is the overall vibration, and it is the time domain measurements monitor the signal amplitude over time. So if there is a change in amplitude over time, the time domain is in charge for that. So for the frequency domain, it isolates each individual components. That's why for the frequency domain, we can detect the or pinpoint the specific defects of our machine. So the frequency domain monitors the signal amplitude by individual frequency. That is why it is easy for us to detect the defect. It is because through frequency domain, it is the one who is in charge or monitor the signal amplitude by individual frequency of that machine. These three kinds of frequency. So in order to do that, in order to identify that, we need some math calculation, which leads us to our question number 6. So how does Fourier analysis helps with your answer in your number 5? So the math calculation we're going to use is the Fourier analysis, specifically the fast Fourier transformation. Why? Because it helps us to break up overall vibration signal by using the math. So specifically the fast Fourier transformation. So how it's gonna work? So I will just explain it to you. So for example, in our rotating machine or in your fan at your home, so there is a debris breaks into that six into that rotating fan. So the frequency of that machine will going to change. So it means that the amplitude is changing. So we're going to detect by using frequency domain, and also by using our mathematical calculation with fast Fourier transformation to detect the changes of the frequency and to detect the defect. So that's it. Thank you.